Hey guys, welcome back to another math lesson with HK Math and Science. This video will be about rules, tables, and graphs, and the learning intention for today is to understand that a relationship between variables x and y can be shown as a table or a graph. And by the end of this lesson, we should all be able to construct a table of points for a rule, be able to construct a graph from a rule or a table of points, and finally know how to find out if a point lies on the graph of an equation. So just pause the video here and take a couple of minutes to write these down. Alright, so let's start off by going through a couple of the key terminology of this lesson. The first is that a rule is an equation which describes a relationship between two or more variables. Also, a linear relationship will result in a straight line graph. So linear just pretty much means straight line. And for two variables, a linear rule is often written with y as the subject. So if you've got a linear rule, it would always be, or most of the time, it will be y equals something. So in this case, y equals 2x minus 3 or y equals negative x plus 7. So these examples down here are also examples of a rule because it describes the relationship between the two variables. So the two variables here are x and y. Alright, now let's go through how to draw line graphs. The first step is to construct a table of values, finding a y coordinate for each given x coordinate by substituting. Next step is to plot the points in the given table on a set of axes, and the last step is to draw a line through the points to complete a graph. This will make a bit more sense when we're going through a couple of example questions, but let's just write these down in our books for now. And now that we've got those in our books, let's just have a go at this question here. It says, for the rule y equals 2x minus 1, construct a table and draw a graph. So the first step here is to construct a table, like it says here, to find a y coordinate for each given x coordinate by substituting. And that means we need to substitute this x coordinate into the rule here for each point. I've gone from negative 2 to 2. You can go further or larger if you want. You can go negative 3 to 3 or negative 4 to 4. But let's just stick with negative 2 to 2 for now. So our first point, we'll know it's at when x equals negative 2. So that is y equals 2. I'm going to substitute negative 2 into x. And that will give me y equals 2 times negative 2, which is negative 4 minus 1. And that negative 4 minus 1 gives me negative 5. So this first point here will be negative 5. And we're just going to do that for each of these points. Next one is y equals 2, x is going to be negative 1, so just substitute that in. That's going to give me negative 2 minus 1, which gives me negative 3. Same deal, I'll just draw a line to split that up. Y equals 2 bracket 0, replacing 0 with the x for this next y coordinate. That gives me y equals 2 times 0, which is 0 minus 1, so y is going to equal negative 1. The next point is negative 1. For the next one, it's x equals 1, so it'll be y 2 bracket 1, which is 2 times 1, just remember that. That gives me y equals 2 minus 1, and that gives me y equals 1. And the last point I'll just do down here, y equals 2 when y equals 2 times 2, sorry. Minus 1, that gives me 2 times 2, which is 4 minus 1, and that gives me y equals 3. So this one will be 3. Right, now let's plot these points into the Cartesian plane. First one, I have negative 2, negative 5. Remember that means go to the left 2 spaces and then down 5 spaces. That'll be our first point. Next point will be negative 1, negative 3. Go left 1, go down 3. That'll be right there. Next one is 0, negative 1. That'll be over here. And then we have 1, 1 over here. And next point is 2, 3. That's up here. So that was step 2. I forgot to say that before. That was step 2 here. Plot the points in the given table on a set of axes, and that is our set of axes there. Alright, now that we've done step 1 and 2 of how to draw line graphs, we need to move on to step 3, which is draw a line through the points to complete a graph. So now we've got all the points on the Cartesian plane here. I'm just going to draw a line connecting there. When you're doing this in your book, please make sure you use a ruler. I don't have one on me right now, so I'll just make do with that. So there's one last thing we need to include in this graph. This rule isn't limited to just the x coordinates negative 2 and 2. It can extend beyond that. So I need to indicate that by extending the line a bit beyond those points and drawing arrows on either end, just indicating that the straight line continues on. Alright, now it's your turn. So it's not possible to make a table on Edpuzzle, so I'm going to ask you what the y coordinate is for each x variable. So for example, like this one, I'm going to ask you at x equals negative 2, what is the y coordinate? For this case, it will be negative 5. If I ask you what the x coordinate is at 1, you need to tell me that it's 1 like here. So we'll do that for this table here. So remember, we can find that out by using the substitution rule of substituting this into this equation here, like we did on this previous slide. So So just pause the video here, have a go at this question by yourself, and just unpause it once you finish the table. Alright, so for the first coordinate, I'm going to substitute negative 2 into there. That will give me y equals 3 times negative 2 plus 1. That gives me negative 6 plus 1, which gives me negative 5. So this one will be negative 5. Now I have y equals 3 times negative 1 plus 1. That gives me negative 3 plus 1, and that gives me negative 2. Next one, I'll just put that in there. Next one is y equals 3 times 0 plus 1. That gives me 0 plus 1, which is 1. This one will be 1. Next is y equals 3, 1 plus 1. That gives me, that's 3 times 1. That will give me 3 plus 1, which is 4. And our final point is y equals 3 times 2 plus 1. That gives me 6 plus 1, which gives me 7. So give yourself a tick for each one you got correct there. Alright, now let's plot these onto the graph here. Our first point is 2 spaces to the left and down 5 spaces. That's negative 2, negative 5. Next is negative 1, negative 2, just up here. Next is 0, 1, just up there. Next is 1, 4, just up there. And next is 2, 7. So I just want you guys to think, is this graph, I'll connect this line, is this graph a linear or a non-linear graph? Think about what linear means. So this should be a straight line. I'm sorry, it's a bit wonky, but just imagine that is a straight line. Yep, so this graph is a linear graph. Remember from earlier, a linear relationship will result in a straight line graph. Linear just means straight line. Now moving on to the next question, we're going to decide if the points 1, 3 and negative 2, negative 4 lie on the graph of y equals 3x. So we do this by substituting these coordinates or points into this rule here. Let's start off with 1, 3. So I'm going to substitute 1 into x, remember x comes first, and 3 into y. So y goes into the left, which will be, I'll just write the equation again up here. So y is 3 in this case, over here, and x is going to be 1 over there. So that is saying 3 equals 3 times 1. So 3 equals 3, and that is true. So that means the point 1, 3 does in fact lie on the graph of y equals 3x. So this one, the answer to this one would be true. Let's try the next one, negative 2, negative 4. We're going to substitute these points into here again. X is the negative 2 and y is negative 4. So that gives me negative 4 equals 3 times negative 2. Negative 4 equals 3 times, this is saying negative 4 equals 3 times negative 2, which is negative 6. This isn't true. That is false. So that means these points, 2, negative 4, does not lie on the graph of y equals 3x. So we can decide if a point lies on a particular graph or rule by substituting it into the equation. So in short, we're going to substitute the x into the x and the y into the y. Alright, now it's your turn. Hopefully that made a bit of sense. If it is a bit confusing, just ask your teacher and we'll be happy to help you. Otherwise, pause the video here and have a go at this one by yourself. Alright, so the first point, we're going to substitute this into there again. So 12 is the y and 4 is the x. So let's substitute that in. I'll just write the equation out again. Y equals 4x. 12 equals 4 times 4. That's what it's saying. If you work that out, 12, there's nothing else we can do to that. 4 times 4 is 16, and that is false. So that means that point 4, 12 does not lie on the line. On Edpuzzle, just write false, please. And negative 2, negative 8, let's try substituting that one in. Remember, that's the x and that's the y. That means y is negative 8 and x equals negative 2, so it'll be 4 times negative 2. If you work that out, there's nothing we can do to the negative 8. 4 times negative 2 is in fact negative 8, so that one is true. So this point here does lie on the graph y equals 4x. And there's one last thing we need to know in this lesson, and these are a couple of special lines, special linear lines. There's horizontal lines in which all points have the same y value, so y equals 4. That means wherever you go, y will always equal 4. So the graph will look, I'll just put a couple of points. The line is just going to go straight through the 4. So that should be a straight line again, and it's going to continue on forever. So I need arrows on either end. So that is y equals 4. You might think it's vertical because it says y. But remember, y is that way. Y equals 4, so it's always going to equal 4. So the line will actually be horizontal. Vertical line, a vertical special line, all points will have the same x value. Example here is x equals negative 2. So if it has if it's always got the same x value, that means it's going to be a vertical line. So it's a little bit counterintuitive, but there we go. If x equals something, it means it's a vertical line, and if it's y equals a constant number, it means it's a horizontal line. Alright, so that brings us to the end of this video. Hopefully you guys did learn something from that, and hopefully by now you guys can construct a table of points for a rule, can then construct a graph from a rule or table of points, and finally know how to find out if a point lies on the graph of an equation. That was using that substitution method towards the end of the video. Once again, thank you guys for watching, and I'll see you guys all back online.